All right, let's talk about water. Jumping into our test scene, the first thing to keep in mind at this current moment is that Unreal does not support tessellation anymore, at least in Unreal 5. So for stuff like water, you'll be wanting to pre-subdivide your kind of water meshes. I have one in this example project. Now, one quick thing to note with this plugin, if your water is a translucent material, so if I set this to default lit, but translucent, you can see that the water looks really jittery when we move. Now, I'm not 100% sure why this happens, but I know what is happening, and that is that the translucent material is reading data from the previous frame. And that's why the position of the render target is jittery. So for the time being, it's very much advised that you use the opaque single layer water material. Now, I do have a video about single layer water. You can just search that up on YouTube. It's called Single Layer Water. And that will kind of take you over the basics of how it works. But that's just one thing to keep in mind with this plugin. Okay, so if we jump into our water, you can see that absolutely nothing is happening. Now, you can see that we are drawing our deform capsules, our solid capsules of the character. Cat, can you not do that, please? Thank you. Now, the reason that we're not getting any interaction is because we need to be drawing all of our water surfaces to our water height runtime virtual texture. So if we go to Prismatiscape, water height, click yes, and in our water material, and in our water material, we need to be making sure that we are drawing the absolute world position into the world height runtime virtual texture output. So if we click go now, then you can see that we're getting a bunch of cool stuff. It looks like water. It looks really nice. So, what is actually going on in our water material that makes it look this damn good? Well, let's dive in. Intentional pun. Very much intentional. Okay, so we are in our water, single layer water material. We are sampling the water, Prismatiscape sample water. This has our water normals output, which is the R and G values. Then we've got the water height, which we use for world position offset. You can also see that there is a function called use blur, and an extra little value, you don't have to put something into it, called the blur distance. Now, this blur is not an expensive blur. It's a Prismatiscape material function called cheap box blur, which just does a a pentasample, samples the original texture, and then copies of the texture in each cardinal direction, which essentially blurs the image. So this is quite cheap to do because these are shared samplers. Basically, it's just better to do this than to double the resolution of the water simulation. So if you're finding that the water is very kind of pixelated looking, just turn on the blur setting with a static bull. Anyway, let's continue. So out of the height map from the water sample, we are taking that, we are multiplying it by 10, and then we're just chucking that into the world position offset in the Z direction. And so that pretty much self-explanatory. It will make the verts move, up and down based on the height map from our simulation. That bit's quite self-explanatory. Now, secondarily, we have the water normals, which you may want to add to your existing, water ripple texture or whatever. So if we just had a texture that was called, water, and you were just doing like the classic panner, water ripples method where you have like UVs and you say, the speed 0.01, and then you double that and you get this, and you do one in the other direction, and then you blend angle corrected normals, and you put that one into that one, then what you would want to do is blend angle corrected normals again using the normals from the water output. So then we can chuck that into our normals. We'll just see what that looks like real quick. It's quite extreme. And so now if we go into here, you can see that we're applying the normals on top of the ripples and stuff. Now, the last thing that we want to do, so usually what you'll want to do for refraction is you'll want to get whatever's going into the normals, you'll want to mask out the R and G values, and then divide it by some number, and then add 1. The reason that we add 1 is because a refraction index of 1 means no refraction. So by getting normals, which have negative and positive values, dividing it by 10, so squishing it down into a smaller range, and then adding 1, we're essentially saying the refraction should be 1, except when normals are applied, it should change by 0.1 in, the positive and or negative directions. So if that's a little bit confusing, then too bad. I don't have time to explain further. But you can see here that everything that's underneath is getting all distorted and looks, nice and funky. If I was to get rid of that, that really noisy water texture bullshit from before and just have the water ripples, but with a higher strength, then you can see that everything is nice and smooth. But when we do water, you can see that everything underneath gets all distorted and looks, nice and funkalicious. All right, let's talk about puddles. So the puddles are driven by our puddles parameter in our material parameter collection. Right here, Prismatiscape MPC, scalar parameters. There is one called puddles. Now you might have your own puddles value in your own material parameter collections. All you need to do is in your child of the manager, and just remember to set your material parameter collection as the material parameter collection that this is going to be using. Otherwise, we're basically good to go. So when you set that puddles value, it's a value from 0 to 1, it will be driving a material function called puddle mask. Now this mask uses a height blend with a texture right here, which by default is the Prismatiscape cloud noise. The tiling size by default is 3000. Now you may or may not want to change this. I find that this is fine for 99% of cases. However, if you did want to change it, you would want to go into this material function and change it to whatever the texture is. And then you would also have to go to the Prismatiscape Niagara Grid drawer and go to the Get Water Puddles and change the texture and also the texture's tiling right here. Now, the reason for that is that the puddle boundary rendering is purely coincidental. So we're not actually changing our runtime virtual texture over and over and over again when this value changes. We're just running the puddle calculation on the materials and in the Niagara thing. Because obviously we don't want to be updating our runtime virtual texture often if we don't have to. So if I press P, we're now changing our puddles to be 0.5, and you can see that we have the puddles and the boundaries are updated. And when they're like this, the boundaries are also updated. So you can see this is where water ripples are allowed to occur. So we've got our little puddles here. And if we go over this way, you can see this big black part here where the alpha is 1. That's just a body of water. So that's how our ripples are actually getting, bounded, is by using this channel. When I press P, you can see that all of these other puddles appear, but clearly some parts are excluded from being puddliest, is through the use of the water data runtime virtual texture. So if we go into a material, for example, these ones here, and we go into here, we can actually look at the runtime virtual texture output. On a material, if the roughness is set to 0, it will never have puddles on it, or it will never allow ripples to propagate through it. If it's set to 0.5, then it will be the default puddle type. So that's like, you know, this sand here is just at 0.5. 0.5 is also just the default. And then if it's set to 1, it will essentially act as a body of water, according to, you know, this render target. So you can see here, you know, even though we're not actually seeing any ripples are still propagating through this stuff. Now, one important thing to note is that you can use vertex color to enable and disable the puddles. If we just get the vertex color and put that into the base color, then we can see that these parts are painted blue, or they have blue set to 1, and then other parts have blue set to 0, meaning that they're going to exclude puddles. Usually you might want to like exclude puddles from the edges. We can even just do that in real time now. We can subtract from the edges only, which means that puddles are never going to form on the edges of this mesh. You know, even if the puddles would usually randomly occur in that location. And then we can say, oh, there's always puddles here by drawing 1 in the blue channel. We press P for puddles. You can see that the puddles that were already there are going to grow first, but the black sections are never going to get puddles on them. So that's just really handy for, you know, level design stuff. So you can see in this material, I'm using vertex color into our puddle mask as the puddle vertex color. The puddles value goes into the puddles 0 to 1. And the height map is just if you've got a height map for, you know, the texture that the puddles are appearing on, that's where you'd put that. We can also add the water ripple height map. So just the Prismatiscape sample water, get the height map, put that into there. And the reason we put that in there is because we can make the water ripples sort of go up and down the height map. So it looks a bit more three-dimensional, which I think is pretty neat. So this vertex color gets used in the generation of the puddle mask for that material, but it also goes into the runtime virtual texture output into the roughness channel. Now, the last thing on the topic of puddles is adding the deform trails to the puddle mask. So if we just draw a bunch of stuff here, you can see that we're creating new puddles using our body. So all that we're doing there is, again, if we go into this material, we can have a look. If we look at the puddle mask in this material, we have the deform footprints input, which can just be set to 0. But this is just, if we follow the node, sampling from the Prismatiscape sample surface, and we get the surface height map. So that will have like the divots where the footprints go in, and it will rise up slightly around the edges. And that is just getting factored in to the puddle mask in the material, but it also gets factored in the Niagara Grid drawer system. So there you have it. That's everything that you need to know to get started with the Prismatiscape interaction plugin. If you do have any other questions, you can contact me on Discord. There will be a channel in my usual Discord for, technical tech support to do with the plugin. Implementing some of the effects does require a bit of materials knowledge, so you can check out my 5-minute materials playlist if you haven't watched it already, which should kind of cover, if you're not sure about like what world position means and what pivot point means and all that kind of stuff. Those videos should answer any questions that you may or may not have. So with that being said, we say goodbye. Goodbye.